All right, good morning. Are we on recording? Everything is good on the back? Okay, wonderful. So good morning again. Aseem, Parikh from ONF. And you are the brave souls who have wandered all the way to the end of this corridor on a Friday. So you must be really open networking enthusiasts. I think you should deserve a big hand. All right, so who from here, obviously a lot of familiar faces here, but who from here has not heard of ONF? Anyone? Okay. Who has not followed what ONF has been up to for the last 12 to 18 months? Anyone? Oh, good. Then what are we doing here? Okay. Who attended the ONF workshop on Wednesday morning? It was Wednesday, yeah. Anyone attended okay, good. Then at least you have something new to hear. And who was at Guru's keynote, which talked about okay, so some of you attended that. So before we jump into what I'm going to do, I'm going to set your expectations right. I'm not the technical expert. We have plenty of technical experts in this room from the ONF community as well as on the floor. What I specialize in at ONF is the what and the why, not the how, okay? And my goal is to make sure that, a lot of technology enthusiasts get very excited about the how to solve the problem, but why are they solving the problem is something they really don't think through very hard. And my goal is to make sure that I bring that to ONF, thanks to our operator-led board and our partners. Operator-led board and the operators have obviously one particular angle. Our supply chain partners have a different angle, and both of them are equally valid, and both of them are for-profit organizations. They have to make money in doing this, and it has to be a transition. So my goal is to make sure that we just don't get too carried away with doing the open source part of it, but make sure there is a go-to-market strategy which can be adhered to. So that is what I'm going to speak about. But you already know this, so I'm going to quickly go through this. ONF is an operator-led organization with the top-tier operators on the board, and we are all collaborating in this consortium to address this very common problem, cloud-like economics and agility. That's what the foundation of this is. And if you see our board and our top-tier partners, you see the who is who on the operator side, but the vendor community is very, very different than you would expect in a typical networking community, and that is for a reason. They have handpicked and encouraged the new style vendors who are committed to this disaggregation, open source, SDN, NFV, cloudification, to become part of the ONF community and ONF membership. And these two groups, in addition, there are about 18 or so, 15 or so other innovator operators who are all working together in driving this. And then there are other 70 plus innovators who make up the community. And so there's a pretty vibrant community, have done a lot of work and is continuously a few steps ahead of where the industry is today. So that is our goal. Our goal is to think about what comes next, where the puck is going to be next, right? And that's what we do. Okay, so enough of the introduction on ONF. We'll talk about what our topic of the day is, cloudification of the multi-access telco edge. And some of the words you might have heard, but I want to make sure that we define it well and define the key drivers for those, the telco edge versus the edge versus the cloud. So we'll talk about that. What is the genesis of this open source work around the telco edge? Most of you know where we come from, the core thing. We'll talk a little bit about that just to brush up. And then we'll focus on the path forward, again, looking forward, where our operators want to be, where the industry is telling us they want to be, and how are we going to do it. All right, so as all in the room would recognize this state of the world today, we have largely a telco network is access and core. There's obviously some aggregation in the middle, but we don't want to get into that level of detail here. And it connects the users, either mobile users, UEs, or home users, or business users, to the network, the internet, and that's their business. That is, the E node B, the G node B coming with 5G on the cellular side, and one popular application for broadband networks now is the OLT, the optical GPON side, which has ONUs and OLTs and all of that on the access, and the equivalent of the core roughly is BNG, right, which is doing the same kind of subscriber management functions of the cellular packet core authentication and all of those things. And finally, they connect. But really the reason this infrastructure exists is people want to get to applications typically in these days running in some public cloud or some private cloud somewhere away from where the users are. And if you see in the typical central cloud these days, one more click back, sorry. There is this either virtualized VM-based or container-based service graphs which are running in that central cloud, and that's what is providing service. And this is a very simple version of this that can be pretty complicated, and multiple service graphs talk to each other and all of that. But just focus on a simple kind of view. This is how typically the world is today. So now, let's talk about the telco edge drivers. If you see today, the popular way of accessing that service running in the cloud is obviously from a mobile phone or a laptop or a desktop. But very soon, what we are getting ready for, and that's what, again, looking forward, is this tsunami of what I call, and I think was called yesterday, hyperconnectivity, with things like multiplayer gaming, AR, VR, intelligent sensors from all types, industrial, home, office sensors, drones, self-driving cars, and the list goes on. And you've heard this 100 times before, so I don't need to list everything out. But this is what is really going to drive the next evolution of what happens in the infrastructure of the telcos and the central cloud. Okay? So what are the two drivers? If you kind of distill these things down, there are two types of things which are required for this edge cloud to deliver. And that is dynamic content. It used to be, we have obviously lived with CDN for the last 10 plus years. This is dynamic content. This is where AR, VR comes in. This is where gaming comes in. This is where multiplayer gaming comes in. It is very different than, getting a movie from Netflix. The future is going to be a little different. And obviously IoT, the talked about thing for the last 5 years, finally looks like it is coming to bear, right? And when I talk about the central cloud being outside the infrastructure, obviously we should not ignore that the telcos have started creating their own clouds, right? And I don't differentiate too much between the telco cloud and central cloud for this kind of high-level presentation, but there is difference by no means. Telco clouds is where the ONAPs of the world run. A lot of billing information happens, and that because it's virtualized, now it's there. And what I'm going to speak to about the service chains and service meshes in central cloud equally applies to telco cloud. Okay, so for now, just kind of consider when I say the central cloud, consider amalgamation of telco cloud and central cloud, the public clouds. Okay, so now as we start looking at this, what it takes to do this dynamic content delivery and IoT support, there are pieces of that service mesh, which I kind of changed the color to green, which identify things which are more latency sensitive, more performance sensitive, needs to collect a lot of traffic and needs to be closer to the edge for obvious reasons because of the performance requirements. So now what is happening is obviously there's a movement which we foresee where this service mesh is going to be split up into these two halves, and that little thing is going to be brought as close as possible to the edge of the network, and that's what the kind of the driver for this whole cloudification of the telco edge is how can we get both the tenant services from public cloud close, as well as telco services closer to the edge in a virtualized manner, which is very efficient to deploy, efficient to change, and more importantly, as those mobile users move from one edge to another edge, the state of that service also moves, which is a very interesting problem which has not been really solved, because you typically, when you're working with a public cloud-based infrastructure, you don't think about mobility as the first-class citizen of that service. In this case, the mobility becomes a very interesting thing, because if the state for that car has to, when you travel from San Francisco to San Jose, you have to make sure that the car's state moves with it from one to another. All right. So that is the first part of kind of setting the context. And please feel free to raise your hand if you have questions. We are a small crowd. We can make it pretty interactive. The genesis of the telco cloud starts in our work, which we did. We have started about maybe 4 years ago around CORD, and with a lot of kind of encouragement from the service providers, especially AT&T. We defined the first generation of CORD, and it looked like this. It looked like a data center. CORD stands for Central Office Re-architected as a data center, or reimagined as a data center. So it looks very much like a data center with servers, white box servers and storage, connected with leaf-spine switches. In our case, white boxes on both of sides. But what makes it different than a typical data center, and what makes it a telco edge, is this specialized access equipment, which connects residential, mobile, and enterprise customers using specialized white boxes. Again, same concept like servers, stack them up, pizza boxes, bring all the software as much as possible, the control software, out of that thing into that middle layer called the open software stack for the telco edge, and then provide services on top of that. So this has been something which has been in works for the last 3+ years. Some of you might remember words like RCORD, MCORD, ECORD. Those were the concepts we started kind of talking about and evangelizing. In more recently, they have been morphed, and we'll talk about that. But before we talk about that, it's amazing to see that even those in the last 3 years, the amount of traction we have had with that concept of virtualized edge. And I'll let you stare at this. I'm not going to read out anything, but if you see about a lot of large telcos in the world are very interested in it. Some of them have it in their labs for a year or two. Some of them are already going to production with it. Some have in fact deployed it today. So this is happening, and this is not me saying it. If you see a couple of analyst reports, this is the surveys they did. 40% of all end customers will have service provided by CORD by 2021 is one survey which was done. The other survey by IHS Markit talked about a 70% penetration of CORD in operator networks. So wonderful. We are very happy that we have kind of gone this far with it. But we also realized that to make this more consumable by operators, the open source components like CORD, the architectural concepts, have to be kind of now put into some specifications. And that's what we did to complement this open source components. The operators came up last year and they created this specifications we call reference designs. And those reference designs basically say how operators plan to consume this open source in their networks, right? And in this particular week, we made the first 2 of them public. This is the reference design dashboard on our website. And as you see, both SEBA and Trellis at the bottom are now 1.0 publicly available. They have gone all the way. They have been worked on for the last 8-9 months. And some people in this room have been contributors, very significant contributors to it. So thank you very much for doing so. And this will become kind of the blueprints or the the part of any new RFPs our operators will put out saying, are you compliant with SEBA X version or Trellis X version, right? So a big round of applause for the people who have done it. It's a big milestone and now really creates a standards, what we call a software-defined standard or software-defined specification out of the work which the community did kind of looking forward multiple years ago. Okay, all right, let's fast forward into a couple of other projects. It's always, as a product marketing person, if you don't have competition, you typically are not on the right idea. So at least there's a lot of people now talking about this concept in a different way, approaching it from a different angle. Broadband Forum is an important industry standard organization that ONF collaborates with. And the CloudCO project is a proposal by their membership, which is primarily incumbent vendors. From what I've seen so far, it's not a full solution. It uses some different abstraction to automate the configuration of multi-vendor physical access devices. It's called Broadband Access Abstraction. And we are sharing some common members, and we are working collaboratively to clarify how CORD and the CloudCO projects are going to address these different use cases, and you should expect some joint blogs and white papers in the near future. Okay, the VCO part is sponsored by OPNFV. It appears to be a demo. I don't know a lot about it because not a lot of it is publicly available. It's based on VNFs, which are mostly proprietary and closed, running on OpenStack. I frankly don't come across, when I talk to the operators, maybe I've heard the question twice in my last year and a half, how does CORD or any of the work we do, SEBA, others, compare to VCO? So hopefully there is more coming from them publicly, and we'll find out more. But as I said, both of these are kind of taking either physical devices and abstracting them out, or taking proprietary virtualized VNFs and creating automation kind of framework on top of it. Looking forward, it looks like none of these things would have the legs to take us where we want to be. And especially with the advent of 5G and services which require hyperconnectivity we talked about, these PNFs and monolithic VNFs are unlikely to lead us there, right? And in fact, Ericsson came out yesterday, and if you heard them say very clearly, it said if you want to do 5G, I think the title of the talk was Cloud Native Essential for 5G, right? So you have to think about cloud native, how you have to think about containerization and virtualization. Okay, so let's jump into kind of the charting the path forward, where this is going. Again, you saw this picture. I'm not going to labor it, but the path forward in 3 steps is disaggregation and virtualization, then making those two networks, cellular and broadband, coexist at the edge especially, and it's obviously happening in the core already, and then the convergence of the user plane and control plane into similar components. So you don't need to have LTE or a 5G enhanced core and a BNG function separate, because they basically do the same thing for a subscriber. And if you want the subscriber to seamlessly move between mobile and wireless and wireline, it's best to combine them. So those are the 3 steps forward, and I'm not going to get into the details of how we do it, but just showing you what is possible. This is all being shown on in our booth upstairs, and the experts are there. You can go and talk to them about the details. So the blue pieces on the left is the disaggregation of the RAN, the access piece, using both the ORAN concepts of CU, DU, the CU, CUPS, and user plane. On the right, the red pieces are the core disaggregation. Again, gateway functions, the cups there, HSS, PCRF, and MME being disaggregated. Similar thing is being done in the industry with the broadband network, especially the SEBA work. There is disaggregation of the OLT pieces with VOLTHA and ONS and a virtual OLT function running on top of that on the access side. On the BNG side, we are also doing the same CUPS level user plane, control plane separation with applications like the address manager, subscriber manager, AAA authentication, and all of that running as virtualized, containerized microservices, right? So now that you have this thing disaggregated, now it's easy to start putting things together because they're all running on, in virtualized container mode, being run through Kubernetes and other mechanisms. So here now you see the kind of the first level of the coexistence at the edge, which is again what we are showing up there. We are showing OLT and a radio access device coming into COMAC, as what we call it, and this is being shown. The next step is, now that you have you coexisted, now you can converge. And convergence happens basically using similar looking blocks from wireline and wireless into one. So the example of the ONS, the access level supporting both a real-time, near real-time RIC from the ORAN specification, as well as the VOLT application on the left-hand side. On the right-hand side, you get the BNG control plane and the 3G control plane, and then run a bunch of similar applications on top, as you see there. And then we have done a similar user plane convergence, combining CU, U, GWUU, and the BNGU, right? And we call it CUF, Converge User Plane Function. All right. That was the CUF part, and then this is the control plane part, which I already talked about. And all of this is being now put into a brand new reference design. We call it COMAC, and an exemplar platform is being built. This is just a very high-level thing. It's not settled yet. The reference design team has just been formed, and the community is going to now kind of start defining and detailing out what gets done in what time frames. So there will be a 1.0, 2.0 roadmap kind of thing for the COMAC reference design and the exemplar. And that's what is coming out. So in the few minutes, looks like we are out of time, but I'll just summarize quickly. This is maybe the ultimate end goal. Larry Peterson, our CTO, calls it the holy grail of what the community is working on, and that is the multi-access edge cloud. And the focus, again, is where access meets edge cloud. That's what makes it different than a regular cloud or a regular edge cloud, which is just focused on edge computing. So you've seen this picture if you attended Larry's talk, but let me just quickly go through it. So we already have the wireline part of it through SEBA. You're working with ORAN, and we'll start collaborating with them as soon as their open source pieces come to bear. I think they just announced something this conference. And the COMAC piece brings these two things together, the wireline and the RAN side of things. And then we have the Trellis piece, which brings the connectivity together for that edge cloud. But this is by no means done, right? We are working with a bunch of people to integrate and learn from. So the LF Edge project, which specifically the Crano project, ONAP, are all pieces we are trying to understand what it's going to take. And then what you see on the top are the kind of the things which we have really not figured out. Multi-cloud service meshes, cloud native CNFs. How are we going to do this from the networking perspective? And I think this was brought up yesterday or day before in one of the keynotes. And lastly, multi-tenant. How are we going to support multi-tenants when the edge cloud can take stuff from a third party as well as an operator running in that edge cloud? How do you handle that? So that's the gap analysis which we have just started. Again, by no means this is anything standard. We are not going to have maybe a reference design around this. This work or this thought process will spawn other reference designs and going forward is our understanding. So in summary, I think operators need to cloudify their edges in response for this age of hyperconnectivity. There is no other way. It's just a matter of when, not if. ONF has been at the forefront of leading this charge, thanks to the community we have built around this, and we are very focused on this, the edge, the telco edge, with open source, white boxes, merchant silicon, and the architecture which we have espoused as core. And as you heard before, several operators are on path to production using this architecture. So both COMAC as RD and the MAAC as this kind of meta architecture are setting the path forward towards this access-aware edge cloud. And the key tenets of that mobility is going to be the first-class citizen of that architecture. Multi-cloud service mesh has to be figured out. Slicing and multi-tenant have to be figured out. But if you like what you see and you're excited about it, please come and join us. We appreciate the time you spent with us today, and thank you very much. All right.